Hi folks, today I do a little maintenance of my solar battery system. I have a battery bank here, a 48 volt battery bank consisting of a series of 6 volt gold card batteries, 8 of them in fact, and I'm just gonna do a short video of what to do, what not to do on a solar backup battery bank. And if you are thinking about building your own system and you haven't done it before, and I would recommend these golf cart battery 6 volts. You can use a deep cycle marine battery like this, but this battery is sealed. You can actually open this to add water, but it's not designed to add water. Plus, this has more capacity than that. And these golf cart batteries got a cap. You can open it up and add in water. This is very important because every time you charge the battery, it will lose some liquid, meaning water. It will lose water every time you charge it. It will bubble up. It's not boiling because it's not 100 degrees Celsius. It's only about, let's say, 30 something degrees Celsius, 30 or 40 max. If it gets too hot, then your battery is probably dead. But it's not that hot. It's hot, but it's not that hot. The bubble came from hydrogen gas. It's not boiling. People say boiling, but it's not. So the hydrogen gas escaped, and hydrogen is a part of H2O, which is water. So every time you charge the battery system, all of them produce bubble, hydrogen bubble, and lose water. So over time you have to add in water, and this is designed so that you can add in water. This is not. Well, actually you can, but it doesn't last as long. So this is, the most economical and efficient way if you are thinking about building your own solar backup system. Anyway, so every month or so, it depends on how much you charge it, how much you use it, and how much you charge it. For my system, I have to add in water every month. So when I add in water, when you add in water, make sure you don't add in too much. Too much is not good. Too little is not good. So when you see the water level below the let me get a flashlight here. I'm sure you can see it, but it looks like cardboard paper in there. Those are lead plates. And if the water level drop below the lead plates, it looks like cardboard paper, and that's not good. So you always maintain the water level above that plates, okay? And when you add water, make sure you don't add above the plastic. Let me see if I can use another hand here to point out. Make sure you don't add above this. See this plastic level? This plastic thing here? Right here, where I'm pointing at. Right here. Because I did it a couple times, and when I charge the battery, it bubbles up, and the acid is leaking out of the cap. As you can see on this battery, see the darker parts are the acid leaking out. and when it leaks out, it goes into the terminal and corrode the terminal. So this is what I have here. It corrodes the terminal and corrode the wire, the connection between the batteries, and that will make it less efficient. It doesn't have a good connection. That's not good. So make sure you don't add too much water. Okay. And if you see something like this, right? If you see something like this on the connector terminal, and if you see a blue-green color, that is copper sulfate, meaning that the acid, the sulfuric acid, comes in contact with the copper lock here, connector here, and reacts with the copper and becomes copper sulfate, and the color is bluish green. Okay. But if you see the terminal here white color, that's not good. That the white powder is lead sulfate, and that means it's leaking out of the battery. Okay, stuff is leaking out of the battery and reacts with the terminal here. I believe this terminal here is also lead. But anyway, white is lead sulfate. Lead out of here is not good. But you see blue-green like this, then you know that it's leaking acid, and the acid reacts with this copper. So you just have to clean it up. So there should be nothing wrong with it. Alright. One thing I need to mention, you probably know already, but when you add in water, make sure you use distilled water. Okay, this is the kind of water that doesn't have any mineral in it besides water. There's no calcium carbonate, no chlorine, no nothing in it. Make sure you use distilled water. Okay, tap water is a no-no because it contains a lot of calcium carbonate, and adding in here is not good because you only need lead and lead sulfate in here. You don't need calcium in the battery. It will destroy the battery. So when you have a system like this containing a lot of 6-volt batteries, especially if your voltage is high, like 48 volt, like my system, you will need to always monitor the system voltage. Okay, it's a 48 volt system. At full charge, it is about 51 volt. Okay, 50.8 volt to be exact, but almost 51 volt at full charge. So when your system is running and you just fully charge the system, and it drops below, say, 48 volt, right? Batteries are full, it drops below 48 volt or 47 volt, then there's a problem. Okay, one of these is going bad. By going bad, I mean the voltage drop below 6 volt. Okay, at full charge, one of these will be, let me show you. Okay, at full charge, one of these will be at, let's see if we can do it with one hand here. Okay. I can't do it in one hand because it's not really touching the terminal. But this is 6.3 volt. Okay, this battery at full charge is about 6.3 volt. Okay, 6.35 to be exact. But what I have here, this battery is going bad, and it's only about, let me show you. See that? It's about 3.3 volts. So it's going bad. So if one of these, instead of having 6 volts, it's only have 3 volts. It's lost 3 volts, right? So instead of your system 51 volt, I mean my system, instead of 51 volt, now it's only 48 volts. So now this can only go up to 3 or 4 volt maximum, right? So when you charge the whole system, right, the charge controller doesn't know one of your batteries is bad. It still keep charging at 51 volt, right? But since this can only go to 3 or 4 volt maximum, the rest have to be overcharged. The rest have to increase the voltage in order to reach the full charge capacity of 51 volt, right? So the rest of the system is gonna be overcharged because of this. So that is not good. Overcharging a battery will damage the battery too. If you left it uncharged, discharged for too long, it will be damaged. But overcharging is also damaging. So it's very important that you have to monitor your system all the time to pick out the bad batteries. If you have a lot like this, one of these is gonna go bad very, I would say, not very frequently if you have a new system, but it does go out once in a while. Let's say a couple of years or so, but you have to check it, I would say, every month, because you never know. And if you don't know, you keep overcharging the rest of the system. Overcharging the rest of the system is going to damage the rest of the system, just because one battery is bad. So that's very important to monitor, right? Alright, so there's a question that arises that if you have some of the new 6 golf cart batteries, and you also have some older golf cart batteries, would you mix match them and put in the same system? I would say no, because the reason I just explained before. If one of these go bad, if it's older, it's more likely to go bad, and one of these go bad, the entire system is going to be overcharged and get damaged. So if you get new, like say if you have 8 of these, right, 8 of these, and 6 of them are new, 2 are old, then the newer 6 batteries is going to be damaged because of being overcharged. So I would recommend against mix matching old and new batteries. Okay, if you have old batteries, put them together, or new batteries, just put them together. Don't mix them together because of the reason I just described. So I have another question that a lot of people ask is, if you have a concrete floor like this one, would you leave the battery on the concrete, and would you have something in between to isolate the concrete floor from the battery? And the answer is, it depends on where you live. If you live in Hawaii, where the temperature almost the same, warm all year round, then you do not need any isolation between the battery and the concrete floor. Okay, because the temperature is always warm and always the same. If you live in colder climate, like somewhere up north, like Canada or North Dakota or Connecticut, somewhere up north, when you have very cold winter, then the answer is yes, you definitely need something to isolate the battery from the concrete floor, because in the winter, in a cold winter, the floor is really cold. So if the battery is touching the floor, the temperature of the battery is going to be as cold as the floor. So you need something to isolate the battery, because when the battery is cold, the battery does not work to its full potential. You do not lose the capacity of the batteries. Okay, everything is still in here. It doesn't go anywhere. Okay, different temperature will at different temperature the battery will give out certain amount of energy. So when it's cold, the battery does not give out its 100% potential. Okay, because it doesn't allow the chemical reaction to occur fast enough. So inside the battery here is just chemical reaction. There's no electricity inside the battery. Okay, it's just chemical. In this case, sulfuric acid and lead. So in order for the chemical reaction to occur efficiently, it has to be at room temperature. Okay, or a little bit hotter, warmer. I mean, if it gets cold, the chemical reaction will occur, but it does not occur readily. It is really slow. So while the energy, say you have a kilowatt of power in this battery, right? While the energy at full charge is still a kilowatt hour, but when it's cold, very cold, you will not get a kilowatt hour out of this battery. Probably half of that, and you can only get that much out of it at that certain temperature. And in order to get more energy out of battery, you will need to heat it up to a higher temperature to get more juice out of it. So to answer the question, yes, if you live in very cold temperature, you will need something to isolate the battery from the concrete floor, right? So the battery doesn't get cold, at least as cold as the concrete. It will get cold as the air, where it stays, the temperature, the air temperature, where you store the battery. But it will not get as cold as concrete floor if you isolate it, say with a piece of wood like so, or in my case, I have wood, plywood there, and down here concrete floor I just have a piece of cardboard box, because I'm not that it's the weather, it doesn't get that cold in winter here, so that's good enough for me. Alright, one last thing I want to mention is when you store this in a garage or in a barn, most of the time it's gonna accumulate dust. So as you can see here, this battery has got a lot of dust. Okay, and if it has enough accumulation of dust, it's gonna short out the two terminal. Not as much, but let me show you here. Usually these terminal, they are raised a little bit off the surface. As you can see here, there's a gap. They do that for a purpose, so that when it's when the surface is covered with dust, it does not short out the two terminals. Okay, but when you have too much dust, it accumulates so that it touches the terminal. Okay, if it has enough dust to touch this terminal here, it's gonna be the same on the other side. It's gonna short out the two terminal, and it's gonna be a leak in power. and you do not want that to happen. So you know, the power is gonna leak out because of the short between the two terminals. Not as much, but the more dust, and it depends also on what kind of dust, how conductive is the dust. But for sure, you're gonna lose power because of these two terminals touching with the dust bridge. So make sure that you have this clean once in a while for best performance. And that's pretty much all I have for now. And if you have any question, just put a comment below and I'll try my best to answer it. Alright folks, and thank you for watching.